Hello. Now we are going to look at an introduction to the idea of functions, particularly focusing on inputs, outputs, and what they would look like if we graphed them, if we drew a picture of them. So ordinarily, in algebra type questions, the input is usually called x, which is the side-to-side number, the in-the-door number that we would have on a coordinate system. And f of x, f sends x to something, or y is equal to, are three different ways of writing the output of a function. So our function takes in a number, usually we call that at input number x. The function is a machine that does something with x, and then what the machine puts out, what the function puts out, is what we would label as y, or we could label it in terms of the function and say it's f brackets x. So the function that has an input of x, or the function that sends from x to whatever the output of the function is. So those are the different ways we can often come across for labeling the outputs of functions. And let's look at a more concrete example. Also, our functions and our inputs could actually be called anything, and in a more practical or in a more story-based question, they will often be more sensibly labeled something other than f and x. So if we think about the area of a rectangle, if I was given a story in a question where I had a rectangle, and that rectangle had a width, and then its length, the longer side, was the width plus 3. Well, the area would be the width multiplied by the length, and when we multiplied that out, we'd end up with the width squared plus 3 times the width, giving us the area of our rectangle. So that's what I have written in here. So in this case, the area is written in terms of the width, so the width is the input. If I put in a particular value for the width, I would get a particular area for the rectangle. So I have the function for the area with the input of the width. This is the machine that turns the width into the area. So the area, so capital A for the area of the rectangle is my output. W is the width of the rectangle, and it's the input. If we input 2 units, so 2 for the width, so 2 goes in for the width, so the length would be 2 plus 3 is 5. We know the area should end up being 10 on the numbers, but what does it look like when we put it in the function? Well, we have the area when the width is 2 would be equal to the width squared plus 3 times the width, which gives us 4 plus 6, which gives us 10, as we would expect. So this area machine, this area function, takes in values for the width of the rectangle and outputs values for the area. So that's how our functions work. Now, if we look at this machine here, we're going to write it in our normal function notation. So we have x is our input, and we multiply that by 2, and afterwards we subtract 3. So what does our function look like? Well, f of x would equal x multiplied by 2 minus 3. Or the other function notation would say the function f takes x and it changes it into 2x minus 3. That's the output of the function. So we take in x and it changes x into 2x minus 3. That's what the function does. Or we could also see it written as y. The output y is going to be 2x minus 3. So we can see that any of those could be the way of describing the output. But we're going to use this notation the most. And we're also going to use the y notation quite a lot as well. So f of minus 1. So f brackets minus 1. This looks an awful lot like we have the letter f multiplied by minus 1. But in this context, we would be able to see that that's not what's going on. So contextually, we'd be able to tell that this is a function with an input of minus 1, as opposed to being the letter f, the variable, multiplied by minus 1. So in this context, that's what this is going to mean. And we are going to put in minus 1 wherever there was an x in our function. So we're inputting -1 into our machine. -1 is going into this machine, and what y value should we get out? So we'd have 2 on -1. So we put in a -1 anywhere there was an x in our function, -3. So we would end up with -2 minus 3 is -5. And if I wanted to then think about the ordered pair or the couple or the coordinate for this, x would be -1, y would be -5. So that would be my coordinate. And I'm going to actually draw that over here. So in the door -1, down the stairs -5. Pardon, I had to change my grid. So we're at in the door -1, down the stairs -5. So start at the origin, in the door -1, down the stairs -5. So that's my first point. F of 0 would mean 2 by 0 minus 3 ends up being 0 minus 3 is -3. So the coordinates of that are going to be in the door 0, down the stairs or up the stairs -3. F of 1 means 1 goes anywhere there was an x. -3, so I have 2 minus 3 is -1. So I end up with a coordinate of 1 minus 1. And f of 2 means a 2 goes anywhere there was an x. So I have 4 minus 3, which gives me 2, sorry, which gives me 1, which gives me 2, 1. So I can put those points down. So I have 0 minus 3, start at the origin, in the door 0, don't go anywhere, and then -3. I have my point there. And then I have in the door 1, in the door 1 from the origin, down the stairs -1. And f of 2, in the door 2, up the stairs 1. In the door 2, up the stairs 1. And we're going to draw in a nice straight line for those points. Something to notice when we draw in our straight line is the connection between the slope of the line and the number here. So if we think about what's happening, every time we increase x by 1, so if we increase x by 1, we increase our y output by 2. And if we think about what the slope of a line is, that would be how fast we rise for how much we run across. If we rise a lot when we only go across a little, that means we'd have a steep slope. So our slope comes from the number in front of the x, because if we increase x by 1, we're going to increase y by 2. So this number in front of the x gives us our slope. And that's an important idea to keep in mind as we go forward with functions. So again, we've gone from any point you like, across by 2, run across by 2, run across by 1, rise by 2. Or if we run across by 2, we'd rise by 6, which is the same fraction. It would also simplify to 2. Now, here we've been given x values and we wanted to find our y value. What happens if we're given the output? We're told that the output of the function, so our y value, is 0. Well, I know the output of the function is my f of x, so that means that 0 is equal to 2x minus 3. And can I find the value of x that solves that for me? Well, this is just rearranging an equation. So I add 3 to both sides, and I have 3 is equal to 2x divided that, so it's by 2, and I have x is equal to 2/3, which you can 3/2, which you can also write as 1.5 if you prefer. So that means my coordinates would be in the door 1.5, up the stairs 0. As an aside in terms of language, this is also called the root of the function. So where this crosses y is 0, so the x-axis, we're crossing y is 0 at 1.5, that's called the root of the function. So the root of f of x is where we cross the x-axis. Now, if we are given the y value is 1, what would we expect that to be? So the y value is 1, we're expecting the answer to be 2. Our x value to be 2. So 1 for our y value is equal to 2x minus 3. Rearrange to get x, plus 3, plus 3. And we get 4 is equal to 2x, divide by 2, divide both sides by 2, and we get x is equal to 2. So our coordinate would be x is 2, y is 1. We actually, I think, already found that one. Yep. And then f of x is equal to minus 2. So where is f of x equal to minus 2? Well, that's when our line is at minus 2. So I'm expecting it to be somewhere around 0.5. And we'll do that equation. And we do, in fact, get 0.5. But we always do need to work it out. Now, g of x. So we have another function, g of x is equal to minus 3x plus 2. So we take our input, multiply it by minus 3, and then add 2 to the result. And these are our different ways that we could write the same thing. So we're going to go through and put in our input of x is 0. And we get 0 plus 2 is equal to 2. So that means we'd get the coordinate 0, 2. And we'll do that for these values. And just to link this now that we have all of our coordinates done out, our x input and our y output all put out, we can draw in our blue line for g of x, our in the door and up the stairs for each one of our coordinates. And we can see here that if we run across by 1, we drop by minus 3. Run across by 1, drop by minus 3. And that again is the number in front of the x. If we increase x by 1, we drop y by minus 3. Now, what happens if we get our y value is equal to minus 2? So that's our y value, our output of our g of x function. So we set our function equal to minus 2 and solve as before. Minus 2 from both sides to get the x by itself. And we have minus 4 is equal to minus 3 all over x. Divide both sides by minus 3. And we get x is equal to 4 all over 3. Minus divided by minus is plus. So we would end up with 4 all over 3, or 1/3, and minus 2. And what happens if we get g of x is equal to x? It doesn't matter that this is a little bit different. We just set x is going to be our y value. So when is y equal to x? And we set that equal to 3x plus 2. And we want to get our x's by themselves. So we can add 3x to both sides to get x by itself. We get 4x is equal to 2. Divide both sides by 4. And we get x is equal to a half. So a half and a half. When would g of x be equal to f of x? This is also called the intersection of g of x and f of x. And the fact that that's a reference to sets is not an accident. So we would simply set the two equations equal to each other. So f of x, or g of x should say, is minus 3x plus 2 is equal to 2x minus 3. And we solve it. And we get x is equal to 1. And if we go over to our graph for a moment, where are our functions equal to each other? Well, that might mean where they cross. And that is, we can see at x is 1. At in the door 1 is where our y values are the same, where our lines cross. And that's our intersection. Now, if they give us something strange like f of 2a, you just put 2a anywhere you had an x in the equation. And you end up with 4a minus 3. And if they give you something very strange like this, you just sub in again and simplify.